Hi everyone. In today's session, we shall discuss about major and minor losses in pipe fittings. In this section, we will be knowing what is the Darcy-Weisbach equation and types of minor losses. So whenever a fluid is flowing through a pipeline, we can see two kinds of losses. One is major losses and the other is minor losses. Major losses are the losses which are caused due to friction, and the minor losses are caused due to a contaminated parts, or where there is a sudden enlargement of the pipe or sudden contraction of the pipeline, or maybe at the end, or there may be entry of the point. So first we shall go with major losses, that is loss of head due to friction. This can be done in two kinds. One is Darcy's Weisbach equation and the other is SIS formula. So first we shall derive the head loss due to friction using Darcy's Weisbach equation. So now let us take a pipeline in which the inward force of the pressure of the liquid is P1 and the opposing force, let it be some capital P2, and the frictional force acting, we all know that if the pressure force is in the one direction, the frictional will be in the opposite direction. So we are taken F. Now let us take a cross section like this, 1 and 2, 1 1 and 2 2, and the distance between the 2 points is, let us be L. Same whatever we discussed. The pressure at point section 1 is 1 and the velocity at section 1 is V1. Similarly, at section type pipe 2 is P2 and pressure velocity is V2. We know that the pressure S1 is greater than S2. So P1 will be greater than along the P2. So this is the most important principle we'll be using is we'll be applying the Bernoulli's principle, and the most important application of Bernoulli's principle is also to find out the loss of heads. So we all know the Bernoulli's principle or Bernoulli's equation, sum of all the heads are constant in two sections. So P1 by plus half rho V1 square plus rho G1 H1 is equal to P2 plus half rho V2 square plus rho G H2 plus the loss of head due to friction is taken as HF. So this is nothing but Euler's equation. I am converting the loss of P1 by rho G plus V1 square by 2G plus H1 is equal to, where H1 and H2 are the datum heads. Okay. And as the pipe is in horizontal position and the H1 will be equal to H2. So we can neglect this, and we are assuming to be uniform velocity. Why? Because it is uniform diameter. So V1 is also equal to V2. So the compressed equation of 2 is P1 by rho G is equal to P2 by rho G plus HF. From this I can write it as HF is equal to P1 minus P2 by rho G. And we said that there is a frictional force which is acting opposite to the pressure force, and the frictional resistance is expressed with the help of Froday's formula. The Froday's formula states that frictional forces is nothing but friction acting with respect to wetted area into velocity square, where F dash is frictional resistance per unit area per unit velocity. So F dash, area of pipe is 2 pi RL circumferential area into velocity. So pi r 2 pi 2r can be written as d. So pi dl into v square. So total F is equal to F dash PL into v square. So HF is equal to P1 minus P2 by rho G. So the pressure force is acting on the liquid on two sides. P1 is equal to F1 by A, and at second section is P2 is equal to F2 by A. So the total sum of forces will be equal to 0. So pressure in the first section is in the straight direction, and in it is opposite direction. So P1A minus resolving forces, P1A minus P2A minus frictional force is equal to 0. So we can write P1 minus P2 into A is equal to F. So if we take this equation, P1 minus P2 is nothing but HF into rho G. So if I take P1 minus P2 as HF rho G HF is equal to F dash PL into V square by A. So HF is equal to F dash PL V square by area into PG. So where P is perimeter and A is area. So perimeter by area can be written as of the cylinder 4 by D. So HF is equal to 4LV square by D into F dash rho G, and there is substituting F dash by rho is taken as F by 2, friction by 2. So HF is equal to 4FLV square by 2GD. So this is your Darcy's Weisbach equation, and it is used to find out the loss of head due to friction in a pipeline. I hope you're clear. Now we shall go with types of minor losses. Minor losses just now discussed are maybe due to loss of energy due to sudden enlargement, contraction at the entrance of pipe, exit of from pipe, and maybe in pipe fittings and in vents. Now first we shall go with loss of energy due to sudden enlargement. So now let us take a pipe whose cross-sectional area suddenly increased from one area of A1 to A2, and the cross-sectional parameters of let P1, V1 and A1 with the pressure, velocity and area at section 1, and P2, A2, V2 are the pressure, velocity and area at section 2. So the total pressure forces acting are P1, A1 minus P2, A2, and in between this cross-section there is a P point, at D points, that is P dash into A2 minus A1. So this can be simplified as P dash into P1 minus, this P is nothing but the inlet pressure P1. So P dash can be written as P1, and the simplified resultant forces are P1 minus P2 into A2. We know that force is equal to continuity. So rho Q into V2 minus V1. So on substituting, simplifying, P1 minus P2 by specific weight is equal to V2 into V2 minus V1 by G. And we all know the Bernoulli's equation, P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V square to V2 square by 2G plus Z2 plus loss of head due to sudden expansion. And P1 minus P2 can be written as Hc plus V1 minus V2 whole square by 2C. And we know that P1 minus P2 by specific weight is given as V into 2 by V2 minus V1 by G. On simplifying, the loss of head due to sudden contraction is V1 minus V2 whole square by 2G, where V1 is velocity at section 1 and V2 is velocity of pipe at section 2. So V1 minus V2 square by 2G for determining the loss of head due to sudden expansion. So now we shall go with sudden contraction. Contraction is nothing but the reciprocal of expansion. The cross-sectional diagram will be. So similarly, let V1 be the velocity of flow at A11, A2, A1, A2, V1, V2, and Hc is the loss of head due to contraction. We know that for expansion it is loss of head is Vc into minus V2 square by 2G. So on simplification of with respect to continuity equation, we got it as H is equal to 0.5 into V2 square by 2G. So now the loss of energy at entrance of pipe, it will be, is nothing but K into V2 square by 2G, V square by 2G, and the value of K will be varying with respect to cross section of the pipe entrance. If it is square edge, it is 0.5, and chamfered it is 0.25 inward protection. Okay. At the exit also similarly, the loss will be K into V square by 2G, and the K is always taken as 1 for all kinds of pipe fittings. So these are the sample shortened essays which are asked in your university examinations. Thank you.